So welcome you all for the fundamentals of embedded system. In this video, we are going to see about types of embedded system. So types of embedded system, how the embedded systems are classified in the sense we can classify the embedded system based on the two main factors. One is how it is performing and what is its functional requirement. Depending upon that we can classify. And another method is where I am using my application, where I am using my embedded system and how it is operating. Like application and operation, we can classify the embedded system. In this, first we can see how they are classifying the embedded system depending upon the performance and the functional requirement. In this, based on performance and functional requirement, they are classifying how complex the system is and how it performs the task. They are classifying it as a small scale embedded system, medium scale embedded system, sophisticated embedded system. Small scale embedded system is nothing but if suppose I am using a microcontroller which is between 8 to 16 bit means then it comes into the small scale embedded system. If I am using a microcontroller which is between 16 to 32 bit then it comes into the medium scale embedded system. I am using an embedded system which will have 32 bit to 64 bit. Then it comes under the sophisticated embedded system. If you see here the bits is getting increased when we go from small scale to embedded small scale to medium scale as well as medium scale to sophisticated. Similarly, the programming will also be complex when we go from small scale to medium scale to sophisticated embedded system. Here are some examples of small scale embedded system, medium scale embedded system, and a sophisticated embedded system. First, we can see example of small scale embedded system. Calculator is an example of small scale embedded system. Then medium scale, they are saying washing machine is an example of medium scale embedded system. Then sophisticated embedded system, if I am going for aircraft control or any high different control system, then it comes under the sophisticated embedded system. Here, next we can see how the embedded systems are classified based on the applications and operation. How the application is and where it is used. Depending upon that, they are classifying the embedded system like a standalone system, real-time embedded system, networked embedded system, mobile embedded system, and IoT based embedded system. In upcoming slides, we can see each systems in detail. The first one is standalone embedded system. Standalone embedded system is nothing but it works independently without needing another computer or another network, which means that if the system is there, it works on its own without needing any input from computer or any support from computer or network. It receives the input and processes the data and gives the output. Or everything is happens inside the device itself. So those type of systems are called standalone embedded system. And some of the features or characteristics of standalone embedded systems are it works independently, it has input and output devices and performs specific tasks. Some of the examples are washing machine, microwave oven, digital camera and a calculator. In all these example, it is not depending on computer or network. If I give the input, it automatically gives the output. Next is real-time embedded system. Real-time embedded system in the sense, it's similar like an embedded system where the time is very much important. I mean, if I give some input, automatically it has to respond within some time period. Those types of embedded systems comes in a real-time embedded system. It has to process quickly because I have given some input within a fraction of a second. It has to give the output, means the processing has to be very high. And if suppose some delay happen means it causes serious damages or failure. Okay, so the time constraint is very much important in the real-time embedded system. Key feature is time critical operations. Some of the examples are when we hit a car, the airbag is automatically deployed. This is an example of embedded system. And here some other examples like industrial robotic controller, medical monitoring systems, and a traffic light control system. So everything comes in a real-time embedded system, because in all the use cases, time is very much important. Small delay is also not acceptable. And this real-time embedded systems can be further classified as hard real-time system and soft real-time system. Hard real-time system is nothing but the time, if suppose there is some milliseconds of delay, means it will cause serious damage or fatal, then it comes into the hard real-time embedded system. If suppose some minor delay like 2 to 3 milliseconds delays are acceptable, means then it comes into the soft real-time system. But in both cases, time is very much important. But delay is acceptable in soft real-time system. Delay is not acceptable in hard real-time system. Hard real-time system examples are airbag control system, pacemaker, aircraft control systems comes under the hard real-time system. In soft real-time system, we can take online streaming. For example, I am seeing a video, but my network is low, so it is streaming some milliseconds or some seconds, means I can wait till it load the video. So those things comes under the soft real-time systems. Here is a simple comparison between hard real-time and soft real-time. Deadline is very much strict in hard real-time. Here somewhat flexible when compared to hard real-time. Failure, if suppose failure happen, means that impact is very serious in hard real-time system. Whereas in soft real-time system, that is minor only. Example is, I can say airbag system is an example of hard real system. Hard real-time system. Pacemaker is also an example of hard real-time system. For soft real-time system, we can take video streaming. Next one is network embedded system. Network embedded system is nothing but my embedded system is connected to the network and communicate to another device, means then it is a network embedded system. That is, it shares some data via the wired or wireless network, means then it comes into the network embedded system. Some of the examples we can say network printer, router, home device, smart home device controls, everything comes into the network embedded system. So the main characteristics of network embedded system is it has to connect with the network and it has to communicate with the other device. Often used to control monitoring and controlling purpose only. These network embedded systems are used, like CCTV monitoring also comes into the network embedded system. Next one is IoT embedded system. IoT embedded system also something similar like network embedded system, but here it is connected with the internet, as well as along with that it used to collect and exchange the data. I mean, here in addition to network embedded system, some data are handled in the sense that it comes under the IoT or Internet of Things embedded system. These systems combine embedded hardware, sensors, and internet connectivities. It combines all the things. Normally in embedded system we have the hardware, sensors only. Here it combines internet connectivity also inside its implementation. So key features are, it requires internet connectivity, data collection will be done using the sensor, and it will be controlled using remotely via app or cloud. Like it will continuously read the data, and the data will be fed into the network via the internet, and that the data will be fed into the cloud via the internet, and the cloud will do some decision and it sends some commands to the device via the internet. So these are the things. These are the things. These are the key features of Internet of Embedded System. Some of the examples are smartwatch that we are using, smart thermostat that we are using, smart home lighting system. Everything comes under the IoT based embedded system. So these are the types that we have seen, and it's a description as well as the example. So standalone system is nothing but it works independently. Real-time system is nothing but response within a fixed time. Hard real-time system means where the deadline is very much strict. Soft real-time means deadline will be flexible when compared to hard real-time system. Network embedded system is nothing but connected through the network, where IoT means it is connected to the internet as well as it handles the data also. So this is the types of embedded system as well as the description. In this I have left to one classification like mobile embedded system. Mobile embedded system is nothing but all the mobile devices comes into the mobile embedded system, because mobile we can't completely say mobile is an embedded system, because it do off of the work of our computer, like computer. So they have classified one particular branch for the mobile, and they are saying all the mobiles comes into the mobile embedded system. So that's all about today's session, and thank you. We will meet on next session.